Welcome, everyone, to Topic 1 on Object Technology. Today, we'll be diving into the world of object-oriented programming and exploring the strengths of this powerful approach to software construction and its principles. Object technology is not just a set of principles, but a comprehensive approach to building software systems. It encompasses abstraction, encapsulation, and polymorphism, which are guiding principles that help us create efficient and effective software solutions. But it's not just about principles. Object technology also includes languages, databases, and other tools that support these principles. Strengths of object technology. One of the biggest strengths of object technology is that it facilitates architectural and code reuse. This means that once we create a well-designed object or component, we can reuse it in different parts of the system or even in different projects, saving time and effort in development. Object technology also allows us to closely mimic and represent tangible elements of a system from the real world. This makes it easier to create software that models real-world concepts, such as business processes or physical objects, more accurately. Another strength of object technology is that it provides stability to our software systems. When we need to make changes to a system, we can often localize those changes to a small part of the system, without affecting the entire system. This makes it easier to maintain and evolve software over time. In addition, object technology is highly adaptive to change. Even small changes in requirements do not necessarily mean massive changes to the entire system. This makes it easier to respond to changing business needs or evolving user requirements without disrupting the entire software solution. Object technology also provides a consistent language that can be applied to both system and business engineering. This means that we can use the same modeling and programming concepts to describe and implement both the technical aspects and the business logic of a software system, making it more cohesive and easier to understand. One of the practical advantages of object technology is that models created using this approach are easy to create, change, expand, validate, and verify. This makes it efficient to develop software solutions and ensures that our models accurately represent the intended system behavior. Object technology also promotes flexibility in software systems. With well-defined architectures and the ability to create and implement reusable components, we can build systems that are adaptable to changing requirements and can be easily extended or modified without sacrificing stability or maintainability. Object technology also promotes flexibility in software systems. With well-defined architectures and the ability to create and implement reusable components, we can build systems that are adaptable to changing requirements and can be easily extended or modified without sacrificing stability or maintainability. Another great thing about object technology is that models can be implemented using any object-oriented programming language. This means that we have a wide range of programming languages to choose from, depending on the specific requirements of our project or system. Now we're also going to dive deeper and explore the principles that guide object-oriented programming. Object technology is built on 4 core principles: abstraction, encapsulation, inheritance, and polymorphism. Let's take a closer look at each of these principles and how they enable us to create robust, efficient software solutions. Abstraction is the process of reducing complex or detailed information into simpler, more manageable units. In object-oriented programming, we use abstraction to focus on the most important aspects of an object or system, and to hide unnecessary details from view. This makes it easier to design, understand, and maintain software solutions. Encapsulation, or information hiding, is the practice of isolating an object's behavior and properties from the rest of the system. This protects the object's internal state from external interference, making it easier to manage and maintain the system as a whole. Inheritance is the process of creating new classes based on existing ones. With inheritance, we can reuse code and design patterns, making it faster and more efficient to create new objects or systems. This also promotes consistency and reduces the risk of errors or bugs. Polymorphism refers to the ability of an object to take on different forms or behaviors, depending on the context in which it is used. With polymorphism, we can design software solutions that are flexible and adaptable to changing requirements or scenarios. This also promotes code reusability and reduces development time. Message communication is the process of objects interacting with each other through messages. In object-oriented programming, objects communicate with each other by sending and receiving messages. This promotes loose coupling between objects, making it easier to manage and maintain complex systems. Finally, associations refer to the relationships between objects in a system. Associations describe how objects interact with each other and can help us understand the overall structure and behavior of a software solution. By modeling associations, we can create more robust and efficient software systems. So there you have it, the principles of object technology. By applying these principles, we can design and implement software solutions that are more efficient, maintainable, and adaptable to changing requirements. In our next class, we'll explore how these principles can be applied in practice through object-oriented programming languages. See you in the next topic.